Hey everyone, let's take a look at another problem that we're going to work in Matlab, and this is going to begin our process of doing loops. That's a pretty powerful programming style or capability that we're going to really get into. And there's two kinds of loops. So I've got a problem here with a rocket, and so this rocket is going to be pushed up into the air by some thrust from the engines. And I'm going to call the acceleration due to that thrust. I'm going to make that t. T would normally be a force, but I'm just going to call t the acceleration from the thrust. So we're not going to worry about the mass of the rocket in this particular problem. Of course, the acceleration due to gravity is also acting on that rocket, right? So I'm going to have some t minus the acceleration due to gravity as the rocket rises. And then the engines will stop because they're going to run out of fuel. So they're going to stop at what I'm going to call T sub r for the rocket engine time. Once that time occurs, the rocket's moving up. Now the rocket doesn't immediately start to fall. The rocket still has the velocity in the upward direction. And so it's going to continue to rise, even if maybe this occurs right here. This is the height where T rocket occurs. The rocket will continue to rise and then eventually stop and come back down to Earth. Okay, and what we want to do is we want to create a program that's going to give us some information about this. And I'm going to work this two different ways. But first off, let's talk about the equations that we're working with. So I want to know, where is the rocket? Okay, and we have to figure out the speed as well. So let's do, where is the rocket and what is its speed? Okay, so the idea is the rocket's going to obey a couple of really simple rules. So the acceleration is equal to the derivative of velocity with respect to time. But we're not going to do the calculus for this. What we're going to do is we're going to say, hey, let's go backward to what was this equation before we knew what derivatives were. Well, it was equal to the change. Remember, that's the Greek letter delta stands for change. The change in velocity over the change in time. Well, this is equal to, let me call it V1 minus V0 divided by T1 minus T0. Now we'll make life simple, and we're going to assume that V0, that's the initial velocity, and that's going to be equal to 0, and T0 will also be equal to 0. But that doesn't have to be the case. In fact, it's really more generic for me to write this way. I'm going to use a subscript of k, where k is just some integer value, right? So k is equal to 1 to n, where there are n steps in this process. Now, I may not know what n is right away, but that's all right. So what I could do is I could say, well, the change in velocity is v sub k. What was the velocity previous to that? Well, it was v sub k minus 1. In other words, my subscript is 1 less. So this might be v7 minus v6, right? Where I've gone through, I'm at step 7 now. So it's the velocity at step 7 looks at the velocity at step 6. And then down here, t sub k minus t sub k minus 1. All right, so the acceleration I've got. So now I need to figure out the velocity. So I can now multiply that by t sub k minus t sub k minus 1. And that's going to equal v sub k minus v sub k minus 1. And so the velocity at some point k, that's going to equal the previous velocity. If I bring this over to the other side, right? So I can say then that v sub k equals the previous velocity plus the acceleration times the time between k and k minus 1. All right, so that's going to be my formula for the velocity. All right, I can do the same thing for distance. Remember that I'm going in the y direction here, right? So I'm going to say that change in y over change in time equals velocity, right? And so in a similar fashion, I can say y sub k minus y sub k minus 1 equals v And I'm just going to stick with delta t here. And here's my idea. The time interval will generally be the same in this kind of a problem. That may not always be true. But I'm going to say in this kind of a problem, the time interval is going to remain the same. And so that kind of simplifies this. And so what I can say then is that y sub k equals y sub k minus 1, the previous position, not the initial position, I was about to say that, the previous position plus the velocity, which we'll have to talk about that in some length as well. Which velocity am I talking about? The previous velocity or the current velocity times delta t. And what we'll discover later on is previous velocity or current velocity makes very little difference if your time intervals are small. And we'll get to that. Okay, so in MATLAB and most computer languages, what I do is I give these values to a variable, and that variable has some designation. And so this is actually going to be rewritten. Okay, I'm going to rewrite this. And right now my A is not too bad. Later on it'll become more complicated, but let's just look at it now. So the way I'm going to rewrite this in MATLAB is I'm going to say V equals V plus A delta T. Now that seems really weird because then I got V on both sides subtracted out. That's not what the software is thinking. What the software says is the new velocity is the old velocity plus A, the acceleration, times the time interval. So all I'm doing is then I take this value on the right-hand side and I reassign it to that same value, right? So V now has a new value. So think of this as a box. And what I've done is I've got a certain amount of toys in the box. And what I've done is I'm going to add another toy. And so now the box has a different amount of toys. And then later on, I'm going to add another toy. And so the amount of toys in the box is bigger. But this is the box. V is the box. So I take the box with 10 toys, I add in 2 more toys. Now the box has 12 toys. Then I clean up the room a little bit more, and I have 3 toys. The box now has 12 toys. I add 3 more. Now there are 15 toys in the box. Right? So the box, the value of the box is changing as I add in more toys. All right, so that's my assignment of variables. What I want to do, and I'll show this to you in Excel, because we've done this in Excel, but Excel has a looping process. I'm going to looping in quotes. It's just a copy and paste is all it is. But we're going to do this in MATLAB, and we're going to loop. So there's 2 kinds of loops that we're going to work with, and I'll get to in more detail when we get actually into MATLAB. But first off, there's the for loop. Now the for loop is going to have a specific number of designations. And so I might say, hey, maybe T sub r is 10 seconds. And so I'm going to do this every second. Right? So if T sub r is 10 seconds, and I'm going to make my time interval equal to 1 second, then I'm going to recalculate this 10 times. I'm going to calculate it maybe 0 times plus 10, or the 0th time plus 10, so maybe it's 11 times. So I'm going to do it for time equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all of those amounts of times are known. And so what I do is I run through the loop 10 times. And so I'm going to say for t equals 0 to 10 in 1 second increments. I'm not going to say it exactly like that. I'll show you the syntax in MATLAB when we get there. But that's going to be the idea. So the for loop, however many times I'm going to run the loop is designated already. I do that automatically. I tell it, go through this 11 times or 10 times or 5 times or whatever. If I wanted to make the interval 1/10 of a second, I'd run through it, say 100 or 100 times, right? Or 101 times. Depends on that first iteration. All right? Order is going to make a difference, and I'll show that to you when I get to that. The other type of loop is a while loop. And a while loop would be really good if I'm trying to figure out how long is this thing in the air. So I don't know, I know the 10 seconds, but I want to know how long is it in the air. So I might say while y is greater than 0, go through the loop over and over and over again as long as y is greater than 0, because when it hits the ground again, y is not going to be equal to 0. I'm going to run another calculation. I'm going to get a negative y, which means it's underground, right? That's nonsensical. So I'm going to stop when I reach 0. Well, of course, I might not reach exactly 0. It might be at 0.005, and then I run the loop again, and it's negative 0.002. Then it stops, because my y value is now negative. So while y is greater than 0, it's going to run through the process. Okay, and that's the idea behind a while loop. All right, so there's a for loop, there's a while loop. And this rocket example is a good example for both of those, because it's going to give me a real good idea of how and why would I use one loop, and how and why would I use the other loop. Okay? All right, so when I get down onto MATLAB, we'll talk more about the syntax and how that needs to look in the MATLAB program. All right, if you have any questions, please do leave them in the comments below. Thank you.